Hello, this is Sumanto Day and welcome to SDA Lessons. Today my subject is physics and the topic is electricity. I have already told earlier the elementary things about electricity. I have mentioned about electric potential, potential difference and current. Today I will delve in Ohm's law. Let's conceptualize Ohm's law with a very simple example. First, imagine of a river whose gradient is steep, and a river, this is a mountain river, the gradient is more. This is a plain river, the gradient is less. What do you expect the flow of water in a mountain river? The flow of water will be fast in the faster. Here when the potential difference is more, then the flow of electrons will be faster. That means the current will be more. But here when the gradient is less, then the flow of water is slow. Here also when the potential difference is less, then the flow of current through it or flow of electrons will be slow. This is the base of Ohm's law. Let's understand. I have made a very simple circuit. Here is a cell, here is a voltmeter that measures the potential difference. Here is an ammeter that measures the current. I have joined one cell, and here is a resistor, means it may be a wire like nichrome which offers high resistance. Now the moment I switch on, here I haven't made the switch. The moment I switch on or connect, I'll read this potential difference and the current, and I will write you V1 by I1. Say it is 5 and 2. Okay. Now second, let's put another cell. Here one more cell. So two cells. So what happens to the potential difference? Increases. Suppose it got increased to 10. This is 10. Current also proportionally got increased. It is 4, say. Third, you take one more cell. Again measure the potential difference. Say it is 12.5. V3 is 12.5. And the current is, say, 5 ampere. This one. What do we notice in all these three cases? Their ratios are constant. 5 divided by 2, 2.5. 10 divided by 4, 2.5. And 12.5 divided by 5 is also 2.5. So this is constant. This constant we call it as resistance. Symbol R. This constant. This is Ohm's law. So what is Ohm's law? The ratio of the potential difference in current is constant, keeping the other thing constant, like temperature, like the wire, without changing. That is Ohm's law in a simple way. Now if we cross multiply, we can remember this formula in a very simple way. V equals IR. Potential difference equals current into resistance. Potential difference measured in volt, V. Current measured in ampere, A. Resistance measured in ohm, here. Alright. Now this resistance If I change it with another wire, will the value be 2.5? No, it will be different. On the nature. If instead of nichrome I use something else, copper, it will be different. So I have mentioned here that it depends on length, cross section or thickness of the wire and the nature. Okay. So what is resistance? What is this resistance? Resistance is the obstruction offered to the flow of current. When current flows, it obstructs. It doesn't allow the electrons to flow easily. This obstruction is called resistance. Now, we will learn two more things. What is that? Equivalent resistance. If two resistors, instead of one, if two resistors are connected end to end, suppose it is connected end to end, what do we call this? We call it resistance in series, connected in series. How do we solve? Equivalent resistance or the total resistance of this is R1 plus R2. This is R1 to R2, say if it is 2 ohm plus 2 ohm, 4 ohm. Very simple, just add. There is another connection. What is this connection called? Parallel connection. End of this resistor and end of this resistor together, twisted together, other end also twisted together. This is called parallel connection. What you do is, now how do we calculate the equivalent resistance of this? 1 upon this plus 1 upon this. I have written that. Solve that. Get reciprocal. Minus 1 means get reciprocal of that. So 1 upon 2, if it is 1 upon 2, plus 1 upon 2, if you solve you get 1. Reciprocal of 1 is also 1. So what will be the equivalent resistance of this? 1 ohm. Let's see a combination of these two, series and parallel. We call it mixed resistance. Here, this one is just like this one. I have added one more here, one more here. This is for you to think. But okay, let me help you. This one and this one, already I said how much it is coming? 1. So this whole thing is 1. 2 plus 1, 3. 3 plus 1, 2. 5. 5 ohm. So series, parallel, mixed. 3 types of connection with resistance, with resistors, and we can calculate in that way. More in my next lesson because the chapter is lengthy. But in the meantime, you keep on viewing, you like, you subscribe, and also spread to other children, those who are interested in science. Thank you and goodbye.